ma'am.
Okay. See, for example, if it is normal binary search tree, I will just mind the values. For example, the this value should be
The
lesser
parents,
than
ma'am.
my right side value, correct? And
Okay.
whatever value I'm having on right side should be greater than or equal to my root node. This is the condition for BST, that is binary search tree. But there is no constraint for height balancing. There is no constraint for height. It can be the right side can be any height and left side can be any height. The only
Okay.
property is lesser and greater. Okay.
Hmm.
See, someone is in lobby, someone is in waiting. The letter is P. I don't know who it is. If it is proper USN name, then only I can allow. You just inform. I don't know who it is. Okay. And then, but in AVL tree, we have this height balancing also. BST tree, also the height balance. Height balance, how much it is allowed, how much it is allowed. So only one level. So for example, left side I can have like this, and right side I can have like this. That is only one level gap can be allowed. That is, if I consider any node, I have to check balancing factor considering right and left. Here no left, no right, so 0. Here 1 left, no right, so 1 minus 0, 1. Here 2 left, that is 1, 2, so height is 2. Here height is 1, so 2 minus 1, my
This
balancing
one.
factor is 1. Here also no left, no right. So balancing factor is 0. So in all the node following either 0 or 1. Correct. So
Mhm.
this tree, the height balanced binary search tree, we can call it as a AVL tree. Okay. So we'll see how to convert this binary search tree to AVL tree. For example, I'm just inserting any value 5. Sachin Kumar. Sachin, Sachin, you there?
Yes, ma'am.
Yeah. For example, I want to insert 25. Where I can insert?
Ma'am, right side.
Exactly. Right side of 10. That is, I want to insert number 8. Karthik A. Karthik. Karthik A. Number 28.
Yes, ma'am.
Yeah. I want to insert value 7. Where I can insert value 7? Number 7, I want to insert. Where I can insert?
Yes, ma'am.
Chandrasekhar, can you tell? I want to insert the value 7. Where I can insert? Chandrasekhar is? Yeah. I want to insert value 7. Where I can insert?
Ma'am, left, ma'am.
Left of 10. Correct. For example, I want to insert number 30. Where I can insert number 30? I have to insert. Yes, I'm considering here greater, so I should come right. I'm comparing here greater, again it should come right. That is 30 should come here. Okay. So this is first type of rotation we are going to see. Okay. So I'm just writing whether this is left side or right side. First, we will check the balancing factor of each and every node. What is the balancing factor of this node? Number 30. Satyendu, can you tell what is the balancing factor of 30?
0, ma'am.
Very
0,
good.
ma'am.
0, because left is 0, right is 0. 0 minus 0. And what about 25? What about 25?
-1.
Exactly. Very good. That is here 0, here 1. So 0 minus 1, minus 1. And I'm checking again. Here height is 0. And then
-2.
right side height is 2. So 0 minus 2. Minus 2. Okay. Correct. So now I'm checking whether all the nodes following AVL property or not. Whether all the nodes are following AVL property? No. Which node is violating? Which node is violating this
10,
property?
10, ma'am.
10. Good. So
10.
from there, yes, 10. From there, I want to trace 2 level down. That is 1, 2. Correct. The place where the property got violated, from that place 2 level I'm checking. Whether it is left or right. Whether it is left or right. This is left side of
Right,
root
ma'am.
tree or right? Right or left?
Right, ma'am. Right side.
Right, ma'am.
Right side. What about this?
Right also, ma'am.
Right
Right,
side.
ma'am.
Correct.
Right, ma'am.
Right subtree. Correct. So I am getting what? What is the first option? Right. I'm getting right. Correct. So if it is RR, what I should do? I should do left rotation. Okay, this is the first rule. If I'm getting RR, I have to do left rotation. How I can do left rotation? That is, I'm the node which I violated, that node I'm going to rotate. Which node violated? This is the node violated. So I'm keeping these two as such. Okay, and I'm rotating the node which got violated to the towards left side. So I'm just violating this node to left side. So what will happen? I'm just pulling down left side. Okay. So what will happen? So
Side of 25, ma'am, 10.
25 will be here and so 25 will be here and then
10
10,
is
ma'am.
10 will be there,
30.
30.
30.
And the 10 and
These two will be connected. Whether it is proper binary search tree, yes.
Yes.
Yes, ma'am.
And whether it
Yes,
is
ma'am.
AVL tree, check all the places. Whether it is following proper balancing factor. What is the balancing factor of this node? 0.
0,
Zero.
ma'am.
What is the
0.
balancing factor of this node? Again 0.
0.
0.
What about this node?
0, ma'am.
Exactly 0. So it is both BST, also it is AVL tree. AVL tree is nothing but height balanced binary search tree. That's all. Okay. Okay.
Yes, ma'am.
So we will see. So this is the first kind of rotation, RR. So we'll see the next pattern. Okay. I'm just deleting this. So I'm just going to add 3 elements. So any example elements can you tell in this structure? Just any example elements here. Which element I can put?
Okay.
Loudly.
10, 7,
And then
10, 8, and 7.
okay. Okay. Just check the balancing factor of each and every node. What about this node?
0,
0, ma'am.
What about this node?
1,
Good. What about this node?
2, ma'am.
2.
Okay. So this is the node violating that property. So from that node, I am just tracing to level 1, 2 from that node. Whether it is left or right, whether it is left subtree or right subtree.
Left.
What about this one?
left,
Left.
That is, if it is left, that is, if I am getting LL, I have to do right rotation.
Right rotation.
Yeah. What is the second rule? If I'm getting LL, I have to do,
Right rotation.
yes, I have to do right rotation. Okay. So how I can do right rotation? So this node is perfect. This node is perfect. So this is the node violating. So I'm just keeping these two as such, and I'm rotating this node to right rotation. I'm just rotating right. So what is the output? What is the resultant value I can get? So
Ma'am,
it I pull down to right side. So what is the resultant value I can get?
at
So in root node, what value I can get?
7 and 10.
8 will come in root node, and then in leaf node, left side 7 will be there and right side
10.
10. Is it fine?
Yes,
Is
ma'am.
it fine now? Now
Yes.
if
Yes.
now if we check, now if we check the balancing factor, it is 0, it is 0, it is also 0. So it
Zero.
is also properly binary search tree, also height balanced. So it is binary search tree, also AVL tree. So this kind of rotation everyone understood? Yes,
Yes,
the
ma'am.
second rotation.
Yes,
Yes,
ma'am.
ma'am.
Okay, now we'll see with third rotation. Okay, I'm just deleting this. So we'll see the third type. Can anyone tell the values? Can anyone guess the values?
37, 10.
Hmm?
13, 7 and 10.
13, 7,
10.
good, 10. So again, I'm checking balancing factor, height balancing factor 0. What about this node?
-1.
Very good. Others also can answer. What about this node?
1.
Ma'am, 0.
Why 0? This node's height balancing factor. Why 0? What is the height? What is the height? What is the
2, ma'am.
left subtree lengthiest height? What is the left subtree's lengthiest height?
2, ma'am.
2. What about the height of right subtree?
0, ma'am.
So 2 minus 0?
2.
Yeah. So which is the node violating this property? This node, correct. So from that, I'm just pointing 2 nodes down. 1, 2. Okay. Whether this is left or right? Left branch, and this is right branch. But is where I'm getting L and R both. Okay.
Ma'am, can you explain again?
What happened?
Ma'am, can you explain this again?
Yeah. See, if I have like this, so I'm checking all the nodes height balancing property. This node violates that height balance property. So I have to trace 2 nodes down. 1, 2. So here left, here right. Correct. One branch is left, another branch is right. Understood? One branch is left, another branch is right. So if I have this kind of thing, how I can rotate and make the tree balanced? That condition is also there. How I can rotate this tree and make the tree balanced? So how I can make it up? How I can make it up? So there is a rule. If you get LR pattern, see, that is the third rule. Here I am writing. That is the third rule. If you get LR, that is top to bottom, top where the node violated, no, from that, if you get LR, if you get LR, what you will do from bottom you have to do the rotation, that is left and then right you have to do. Sachin, should I explain again? Till this you understood? This is the node.
Yes, ma'am.
This is the node violating property. From that two node, I'm just checking down these two nodes. This is left direction, this is right direction. That is, I'm getting left and right. If I get left and right, how I can rotate my tree to get the balanced? So there is a rule. If I get left, right from top to bottom, I want to do this kind of rotation. That is from bottom to up. Okay, that you should not get confused. First, I want to start bottom place. So this only I have to concentrate 7 and 10. That is, I'm just taking only 7 and 10. 7 and then 10 I'm taking. Okay, what I have to do? If this is the right branch, I have to do left rotation. Okay, I have to left rotation. How I can do? I'm just rotating this node left. So what will happen? What will happen?
10 is the
So 10 will become the root node. Okay, since I am pulling it to left side, and 7 will come here. Understood?
yes, ma'am.
This understood? Sachin, you understood?
Yes, ma'am.
Guys, others understood?
Yes, ma'am.
Okay. So pending node also there, 13 pending node also there. You just, then we will do with that node now. So again, you have to do already left rotation is done. Then you have to do right rotation, correct? Because obviously now you know why right rotation should we have to do. Since, see, just imagine this is 0, this is 1, this is 2. So this is L, again this is L. If it is LL, obviously which one you have to do? You have to do right rotation. So if you do right rotation, what will happen? 10 will
Right.
become, 10 will become what?
Good.
Very good. Root node. 7 will come left side, and then
13 will come.
yes. Is it clear, everybody? Everybody, is it clear how I made this?
Yes, ma'am.
Any doubt in it? How I converted from this
No,
to
ma'am.
this? Everyone clear, guys?
Yes, ma'am.
Okay. So one more example we will take. One minute. So I'm just deleting that, and one more rotation we will see. I'm just deleting, and one more. For example, I'm having like this, like this, like this. Any example can you tell?
12, 15,
For example,
and
15, and for example, 20, and for example, is that fine?
yes, ma'am.
So I'm checking the balancing factor here, 0. What about 20?
-1.
Okay,
1, 1.
actually +1. And what about this node? What about 15?
-2.
2, ma'am. 1, ma'am.
-2.
Here 0. Why 1? Who told 1? How come 1 will come, guys?
2, ma'am.
Here 0 and here the height is 2. So
-2.
-2. Correct?
Yes, ma'am.
Is it right, guys?
Yes, ma'am.
Okay. So we have to balance this tree. So I'm just checking. This is the node violating the property. I'm just checking. This is what? This is what? This is left branch. This is, I'm sorry, this is the right branch, right?
Yes, ma'am. Right.
This is what? Left branch. So from this node, the node which violated, right, left. So I have to do this in bottom up, same right left rotation from the bottom up. So first I'm just considering these two. 20 I am having, and I am having 17. What rotation I should do? I should do right rotation. So I should do right rotation. So what will happen? This step will become 17,
19,
20.
20.
20. Correct? And already one value are there, 15. So after doing right rotation, we have to do left rotation, correct?
Left rotation.
Left rotation, yes. So how you'll do left rotation? I'm just, this is the node violating rule. I'm just keeping these two as such, and I'm rotating this node. So what is the resultant node? 17 will become
17.
root node,
Root node.
and then
Root node.
15,
90.
yes, and then
20 becomes
20. Whether it is BST, whether it is BST,
Yes.
whether it is
by
proper AVL tree, check all the nodes.
30. Yes.
So what is the fourth one? From the top to bottom, if it is oral pattern. If it is oral pattern, then you have to do right left rotation from bottom up. Okay. Right left rotation. Is it clear, guys? Everyone? 4 types of rotation. Okay. So all 4 types of rotation we have done with. Any doubt in this? 4 types of rotation. Any doubt in the with you guys?
no.
These four types of rotation. Any doubt? No, right? Okay. I will give one problem. I will ask someone. You just let me know. Okay.
Okay.
Sorry. For example, I'm having one tree like this. Hmm. I'm just making still easy. Try to fill any values. For example, 15, 8, 7, 6. Yeah, try to make balance tree. Try to make balance tree.
Then we can make 8 is a node, and then
Mm-hmm.
15 is right side, and 16 is right side of 15,
Mm-hmm.
and then 7 is the left side of 8, and 6 is the left side of 7. Then it's make
Okay, we'll wait for others. Who have done? Anyone else? Guys, done?
Yes, ma'am.
Abhishek, Chopra, Chandrasekhar, Gitarani, Sachin. What happened, guys? Nagajna, have you done? Kavya, Chandrasekhar.
Done, ma'am.
Okay, okay. So we'll discuss. So what will happen as he told? So only this part will change, correct? Because we'll start from the beginning. The height balancing is 0, height balancing is 1, here 2, here also 2, and here 0. So from bottom up we will check. So this is the place we have to correct. So how I can correct? So 2 place down I'm checking. This is also left, this is also left. So I have to do right rotation. That is these two, no problem. I have to do right rotation, this part. So I have to do right rotation. So what, how it will become? 15 will be there as such. And then 7 will be here.
7.
And then 6 will be here.
7, 6.
Ma'am, yes, ma'am.
8 will come like this. And 16 will come here, correct? So when
Yes.
I'm checking,
Yes,
when I'm
ma'am.
checking, all the node again will be balanced. That is, this is 0, this is also 0, this is also 0, this is 1, and this is also 0. So perfect BST and perfect AVL, correct guys? Yes?
Yes, ma'am.
Yes, ma'am.
Okay, any doubt in this? Any doubt in this for anybody? No, right?
No,
No,
ma'am.
ma'am.
Okay, so now I'm just altering this tree. Okay. Okay, now what will happen? Each and every node you try to find the height balancing factor.
Ma'am, first of all, we can change a 9 to 9 is a place of 9. We place of it we can change a 9
Okay.
and then 8 is the left side of 9, 7 is the left side of 8, and 6 is the left side of 7 is the left side of 6.
How
Then
have you done? That is we'll start from the beginning. This is 0, this is 1, and this is also
1.
1, this is 0, and here 2, 0. So this is the node where I have to do. I can take either like this, correct, or I can take either like this. So since there is a better, if we choose leaf node, that will be better. So what will happen? So what will happen? Which way you have done? Which way you have done? Which you have chosen first? If I choose like this, what will happen? If I choose 15, 8, 9, what will happen? That is 8 will become root node. Correct.
Yes.
See, if I choose this 15, 8, 9, just we will concentrate only on this. So how I can do? That is, first I have to do left rotation here, correct? So what will happen? 9 will become root node, correct?
Yes, ma'am.
8 will
It
become
is
leaf node. Already 15 is there, correct? So again, if I do the rotation, how it will become? 9 will become root node and 8 will become left side and 15 will become, yes, that is I have done only for 15, 8, 9. Others can be same elements, correct? 16 I am attaching as usual, and then 7 I am attaching as usual, and then 6.
6.
Whether again we have to do? Whether again we have to do? Yes, because in 8 again you have to do, correct?
Yes, ma'am.
So that time what will happen? 7 will come here. If you step by step, if you work out, then only you'll understand. 7 will come here, and then 8 will come here, 6 will go here. See, step by step you have to do. Sorry, 9. Something, 1 minute. No. Something wrong we have done, no?
Yeah, ma'am.
7, 6. Why 8 have came here? 6 here, no?
Yes, ma'am.
Yeah, 6 should be here.